Why do massive ships hide a giant bulbous nose underwater? But engineers discovered a secret that changed shipping forever today. Moving through water creates massive waves that slow ships down. Steel hulls endure immense pressure while cutting through deep seas. Every wave created is energy stolen from the ship's engine. The bulb creates its own wave to cancel the main. This clever trick allows ships to glide with less drag. It is like a submarine attached to a giant skyscraper. Millions of tons of fuel are saved every single year. That detail becomes important later. Beneath the waterline, this giant bulb defies standard ship design. Water creates immense drag against every single moving steel hull. Moving tons of steel requires massive amounts of expensive fuel. Look closely at the rivets and reinforced plating below water. The bow wave acts like a wall blocking forward momentum. Pushing water aside consumes energy that we simply cannot recover. This strange bulge is not just for show or aesthetics. Observe how pressure shifts when the bulb enters the flow. It works silently to manipulate the water before it hits. Next, we see how this bulb actually cancels the waves. Water pressure pushes back against every moving steel giant hull. Every ship creates waves that steal precious engine power daily. Moving thousands of tons requires overcoming massive amounts of drag. Engineers designed this protruding bulb to disrupt natural wave formation. The bulb creates its own wave that cancels the bow. These two waves collide and effectively flatten the water surface. Less resistance means the ship glides through water much easier. This steel nose is reinforced to handle immense crushing forces. Small design changes result in massive fuel savings every year. Wait until you see how these shapes change for speed. That massive underwater bulb creates a wave of its own. It forces water to crash against the ship's main bow. This interference cancels out the massive drag of the hull. Look closely at the rivets and heavy welds holding this. Engineers calculate the exact shape for specific cruising speeds only. It tricks the ocean into thinking the ship is smaller. This simple shape saves thousands of tons in fuel costs. Compare this bulb to a human diver for massive scale. What happens when ships go too fast for these bulbs? A massive bow wave creates invisible drag against the hull. Moving water requires immense energy that is simply wasted away. The bulbous bow acts as a secondary wave generator here. Look closely at the rivets and reinforced steel plating here. It creates a wave that cancels out the main wake. By canceling the wave, the ship effectively glides forward easier. This simple shape saves thousands of tons of fuel annually. Compare this bulb to the size of a small car. Next, we explore how these shapes change under extreme pressure. The bow creates a wave that slows the ship down. The bulb creates its own wave to cancel the first. These two waves collide and effectively flatten the water surface. This clever trick reduces drag and saves massive fuel costs. The bulb must be tuned perfectly for the ship's speed. Hit the subscribe button and press the bell icon to get updates. Modern computers now design these bulbs to maximize total efficiency. It is essentially a giant underwater shield against ocean resistance. Wait until you see how these ships handle extreme storms. Massive ships push forward, creating huge waves that waste energy. This drag forces engines to work harder to maintain speed. The bulbous bow is the secret weapon against this resistance. It creates a secondary wave that cancels the primary wave. Peaks meet troughs, smoothing the water around the ship's hull. Less drag means the ship burns far less heavy fuel. It is like a dolphin's nose, masterfully shaping the flow. Engineers carefully calculate every curve for maximum hydrodynamic efficiency gain. This simple shape keeps our global economy moving every day. Underwater low angle reveals the massive bulb pushing through waves. The bulb creates its own wave that cancels bow waves. This clever design drastically reduces the ship's total water resistance. Engineers measure every curve to maximize fuel savings at sea. Less resistance means burning significantly less fuel per long voyage. Constant speed is maintained without fighting against the ocean's force. Ships evolved from blunt bows to these highly efficient shapes. Compare the tiny bulb size against the entire massive vessel. The evidence points to a much deeper story.